Hello everyone, this is Chemistry Math Made Simple with Ms. Rodriguez, and today we're going over everything you need to know about the pre-mol unit in high school chemistry. So today we're going over significant figures, scientific notation, and dimensional analysis. But first, let's start with some definitions. What is the difference between accuracy and precision? Accurate means that the measurement is close to the right or the accepted value, while precise means that a set of measurements are close to each other. So if we look at the bullseyes here, the one to the left is accurate and precise. So they're close to the correct answer, in this case the middle, and they're close to each other. The middle bullseye is precise, so they're still close to each other, but they're not accurate because they're not close to the middle. The last bullseye, the one on the right, is neither precise, so they're very far apart, and they are also not accurate. They're not close to the middle. For significant figures, there are some rules to follow. The first rule is that non-zero numbers always matter. They are always significant. So in this number right here, the 3, the 5, and the 7 are all significant. The second rule is zeros only matter sometimes. So there are three types of zeros in a number. You have the leading zeros, the in-between zeros, and the trailing zeros. Leading zeros are never significant. In-between zeros are always significant. And trailing zeros depend. If there's a decimal, so for example, this number has a decimal, the trailing zero does matter. It is significant. But if we take away that decimal, then the leading zero still doesn't matter, but now the trailing zero also doesn't matter. So it is no longer significant since this number does not have a decimal. Let's do a couple of practice problems. Go ahead and try this on your own. So pause the video and see if you get it correct. How many sig figs do the following numbers have? This first number, 100 million, has one sig fig. The only number that is significant is the number 1. All of the trailing zeros are not significant since there's no decimal. What about this number? It has 5 sig figs. All of the numbers matter and the zeros matter because they're in between zeros. So all of the numbers are significant. And our last example, it has 4 sig figs. The 2 and the 5 are significant. The leading zeros are never significant, so both of the zeros in front of the 2 are not significant. The trailing zeros are significant, so the trailing zeros do matter here because we have a decimal. When we're adding or subtracting, the number of decimal places for your answer should be equal to the number of decimal places for your least precise measurement. So for example, when we add 1.25 plus 5.0, in our calculator, it's going to say 6.25. However, 1.25 is 2 places after the decimal, 5.0 is 1 place after the decimal, so our answer can only have 1 place after the decimal. So we have to round the 6.25 to 6.3. And now we have the correct answer. Multiplication and division, however, depends on the number of sig figs. So the number of sig figs for your answer should be equal to your numbers with the lower number of sig figs. For example, when we multiply 125 times 5, our calculator is going to tell us 625, which is 3 sig figs. 125 has 3 sig figs. The number 5 is 1 sig fig, so our answer should only have 1 sig fig. So we have to take that 625 and round it to 1 sig fig, which would mean 600 is our final answer. Make sure you keep these rules in mind as they will apply for the rest of the year in chemistry whenever we do mole and stoichiometry calculations. Scientific notation is a way for us to show really, really big or really, really small numbers in an easy way. When you have a really, really big number, so for example, 800,000, that's 8 with 5 zeros after it, the scientific notation for it would be 8 times 10 to the power of 5. The reason for that is because you take where the decimal started, so in this case, the decimal should be at the end of the zeros, and you move it behind your first real number. So our first real number is the 8, which means we have to move that decimal 5 times. That's where we get the power. So times 10 to the power of 5. If we have a really, really small number, so for example, 0.00008, so that's 8 with 4 zeros before it, again, we take where our decimal started, so we can see the decimal, and we move that decimal behind our first real number, so we're moving it right 5 times, and that's how we get our scientific notation, which is 8 times 10 to the negative 5. Notice that when you have really big numbers, you have a positive power, so that positive 5. When you have a really small number, you get a negative power, so negative 5. Let's go ahead and convert the following numbers into scientific notation. Again, pause the video, try it on your own, and see if you get it right. This first number, 626,000, converted into scientific notation would be 6.26 times 10 to the power of 5. Because again, we moved that decimal 5 times to get it behind the 6. Our next example, 0.007809, in scientific notation would be 7.809 times 10 to the power of negative 3. So we need to move that decimal until it's behind the 7, which means we move the decimal 3 times. Notice that in this example, the in-between zeros also get written. So every number that is significant needs to be written when we turn things into scientific notation. And now let's go backwards. So when we have the number in scientific notation already, how do we turn it back into decimal notation? For this first example, 1.93 times 10 to the power of 7. The positive 7 means it's a really big number. We're going to move our decimal 7 times, and we get 19,300,000. For our last example, we have 5.3 times 10 to the power of negative 4. So that means it's a very, very small number, and we move our decimal 4 times to the left. So we get 0.00053. All right, dimensional analysis. So there are 3 steps to dimensional analysis. Basically, dimensional analysis is what we use to convert our numbers from one unit to another. The first step in dimensional analysis is to read your problem and identify what unit you know, so what you're starting with, and what unit you want to end up with. So what's your know, what's your want? Step 2 is to set up your conversion factors so that the units cancel and you end up only with the unit you want. The last step is to do the math. So this is where you plug it into your calculator. Multiply all of your top numbers, multiply all of your bottom numbers, and divide the top number by the bottom number. Make sure whatever answer you get at the end makes sense. For example, if you're going from feet to inches, your number should get bigger, and vice versa. If you're going from inches to miles, your number should get way smaller. So that's an easy way to double check your math. Going over our example, how many seconds are in 1 hour? So starting from step 1, what do we know? What do we want? We know that we have 1 hour and we want number of seconds. Step 2 is to plug it into our dimensional analysis. So we're starting with what we know. We know we have 1 hour and we use our relationships or our conversion factors to turn it into the unit that we're looking for. If we have hours on top, we want to have hour next at the bottom, and we know the relationship between hours and minutes. 1 hour is equal to 60 minutes. If we have minutes on top, we want minutes again on the bottom, and we do know the relationship between minutes and seconds. 1 minute is equal to 60 seconds. We know that we can stop because seconds is the unit we're looking for, and we have seconds at the end. Now that we've set up our dimensional analysis, all you have to do is multiply your top numbers and divide by your bottom numbers. So 1 times 60 divided by 1 divided by 1, and you get your final answer, which is 3,600 seconds. You use this format every time you're trying to convert from one unit to another. All you need are the relationships, so you do need to know the conversion factors. I suggest familiarizing yourself with the common ones. For example, hours to minutes, hours to seconds, days to years. So those are the common ones for time. For length, it would be meters to feet, feet to miles, meters to centimeters, and so on. All right, that is everything you need to know about the pre-bowl unit, which is chemistry math. Thank you so much for your time. Let me know if you have any questions in the comments below. If you found this video helpful, make sure you hit that like button and subscribe so you don't miss any of my future chemistry content. I will be releasing a video soon with more examples from chemistry math if you are needing more step-by-step examples. If you're a chemistry teacher and you would like access to this exact PowerPoint, it is on my TPT store called Chemistry Made Simple, as well as worksheets, labs, and activities that align with this unit and all other units for high school chemistry. I hope you guys have a great day. Bye.